We already have tremendous ecosystem here. We've been here, as you know, for a very long time. NVIDIA is 33 years old. The first time we came to Europe was during the time when workstations and the digitalization of products, CAD, the CAD revolution started. We were here during the CAE revolution, and now the digital twin revolution. Some $2 trillion of ecosystem here in Europe that we partner with and that we have the privilege of supporting. What comes out of that is a new revolution that's happening. As you know, everything that moves will be robotics. Everything that moves will be AI-driven. And the car is the most obvious next one. NVIDIA builds the AI supercomputers to train the model. The AI supercomputer for Omniverse digital twins. We also build the AI supercomputers for the robots itself. In every single case, whether it's in the cloud, for Omniverse, or in the car, we offer the entire stack. The computer itself, the operating system that runs on top of this computer, which is different in every single case. This computer, high speed, sensor rich, must be functional safe. In no circumstance could it fail completely. And so the safety requirement's incredibly high. And now we have an incredible model that sits on top of it. This model that sits on top of it is a transformer model. It's a reasoning model. And it takes sensor in, you tell it what you want it to do, and it will drive you there. Takes pixels in, and it generates path plans output. So it's a generative AI model based on transformers. Incredible technology. NVIDIA's AI team, AV team, is incredible. This is the only team that I know that has won end-to-end self-driving car challenge at CVPR 2 years in a row. And so they're the winner again this year. Let's take a look at the video. Yep, thank you.
Like any driver, autonomous vehicles operate in a world full of unpredictable and potentially safety-critical scenarios. NVIDIA Drive, built on the Halo safety system, lets developers build safe autonomous vehicles with diverse software stacks and sensors and redundant computers. It starts with training. Safe AVs need massive amounts of diverse data to be able to address edge cases. But real-world data is limited. Developers use NVIDIA Omniverse and Cosmos to reconstruct the real world and generate realistic synthetic training data to bring diversity to the AV model. The model can perceive and reason about its environment, predict future outcomes, and generate a motion plan. And for decision-making diversity, an independent classical stack runs in parallel. Guardrails monitor safe performance, and in cases of anomalies, calls the arbitrator to make an emergency stop. Further diversity and redundancy are built into the sensor and compute architecture. Each sensor connects to redundant computers. So even if a sensor or computer fails, the vehicle stays safe and operational. And in the event of a critical failure, the system can execute a minimum risk maneuver, like pulling over to the shoulder. Safety is foundational to autonomous driving. NVIDIA Drive lets developers worldwide integrate Halos into their own products to build the next generation of safe AVs.
A billion cars on the road, 10,000 miles a year on average, 10 trillion miles. The future of autonomous driving is obviously gigantic. And it's going to be driven, it's going to be powered by AI. This is the next gigantic opportunity, and we're working with enormous companies and really fantastic companies around the world to make this possible. At the core of everything we do here with AV is safety, and we're really, really proud of our Halo system. It starts with the architecture of the chip, and then the chip design, and the systems design, the operating system, the AI models, the methodology of developing the software, the way we test it, everything from the way we train the models, the data we provide for the models, all the way to the way we evaluate the models. NVIDIA's Halo system and our AV safety team and capabilities are absolutely world-renowned. This computer was the first one to be software-defined. The world's first software-defined, completely 100% software-defined AI-driven software, AI-driven stack for AVs. We've been at this now for coming up on 10 years. And so this capability is world-renowned, and I'm really proud of it. The same thing that's happening for cars is happening for a new industry. As I mentioned earlier, if you can generate video from prompts, if AI can perceive, it can reason, and it can generate videos and words and images, and just now with cars, the path, the steering wheel path, why can't it also generate locomotion abilities and articulation abilities? So that fundamental ability for AI to revolutionize one of the hardest robotics problems is around the corner. Humanoid robots are going to be a thing. We now know how to build these things, train these things, and operate these things. Humanoid robotics is going to potentially be one of the largest industries ever. And it requires companies who know how to manufacture things of extraordinary capabilities. This speaks of the European countries. So much of the world's industries are based here. I think this is going to be a giant opportunity. Well, let's say it's 1 billion robots around the world. The idea that there will be 1 billion robots is a very sensible thing. Now, why hasn't it happened? Well, the reason for that is simple. Today's robots are too hard to program. Only the largest companies can afford to install a robot, get it to teach it, program it to do exactly the right things, keep it sufficiently surrounded so that it's safe. That's the reason why the world's largest car companies all have robots. They're large enough, the work is sufficiently repetitive, the industry is at a sufficient scale that you could deploy robots into those factories. Almost everybody who's a Mittelstand or small, medium companies or mom and pop restaurants or stores or warehouses, it's impossible to have that programming capability until now. We're going to give you essentially robots where you could teach them. They'll learn from you. Just as we were talking about agentic AI, we now have humanoid AI that can learn from your teaching using toolkits that are very consistent with the NeMo toolkits I spoke about. NVIDIA here as well is built in 3-layer stack. We build the computer, the Thor computer. Dev kit looks a little bit like this. This is a robotic computer, completely self-contained. Dev kit sits on your desk. These are all the sensors. And inside is a little supercomputer Thor chip. Just really, really incredible. And these, yep. Yeah. I could imagine getting one of these inserted like that. Okay. Thank you, Janine. And so that's the Thor processor. On top is an operating system designed for robotics, and on top of that, transformer models that take sensor and instructions and transforms it and generates flight or paths and motor controls for arm articulation, finger articulation, and of course, your legs articulation. Now, the big challenge of humanoid robotics is the amount of data necessary to train it is very, very hard to get. And so the question is, how do you do that? Well, the way you solve that problem is to back in Omniverse, a digital twin world that obeys the laws of physics. And this is an incredible piece of work that we're doing. Don't do it. Don't. Oh, my fault. Okay, these are robots. We develop computers to simulate, to train them, computers to simulate them, and the computer that goes inside them. There's a whole bunch of humanoid robotics companies being built around the world. They all see the great opportunity to revolutionize this new device, if you will. And the progress is going incredibly fast. And the way that they all learn is they learn in a virtual world. And this virtual world has to obey the laws of physics. And recently, we announced a big partnership with Disney Research and DeepMind. And we're going to work together to create the world's most sophisticated physics simulation. And I'm just trying to figure out, at this point, how to go to that slide. Teach me. Who's with me? This is what happens when you only rehearse once. Okay, so this incredible system is where an AI learns how to be an AI. Let me show it to you. We have a special guest. Your name is Greg. Are you a petite garçon or petite fille? Okay. Greg is a little girl. Now, look at this. Greg learned how to walk inside Omniverse, obeying the laws of physics. But inside Omniverse, we created hundreds of thousands of scenarios. Then finally, when Greg learned how to operate and walk and manipulate in those environments on sand and on gravel, on slippery floors, on concrete, on carpet, then when Greg comes into the physical world is just 100,001 version of the world. And so you learn how to walk in the virtual world, and look at you now. Can you jump? Wow. Can you dance? Well, I just want to let you know, I am the keynote presenter. So I need you to behave. I need you to behave for a few seconds. Could you sit? Sit. Hey, you know what we should do? Let's take a picture of everybody. Yeah. Bam, bam. Would you like to come home with me? Would you like to come home with me? Yeah, I know. Yeah, I have pets. They would like to have you as a pet. No? No. You're so smart. You're so smart. Well, incredible, right? You are the world's best robot, and someday we'll all have one like you, and they'll follow us around. But if I need a glass of whiskey, you're going to have to go tell somebody else to go get me a glass of whiskey because you have no arms. Yeah, you're so cute. Okay, little girl, you stay here for a second. Let's wrap up. All right. It's very clear an industrial revolution has started. The next waves of AI has started. Greg is a perfect example of what's possible now with robotics. The technology necessary to teach a robot, to manipulate, to simulate, and of course, the manifestation of an incredible robot is now right in front of us. We have physical robots, and we have information robots. We call them agents. So the next wave of AI has started. It's going to require inference workloads to explode. It's basically going to go exponential. The number of people that are using inference has gone from 8 million to 800 million, 100 times in just a couple of years. The amount of prompts that the tokens generate, as I mentioned earlier, from a few hundred tokens to thousands of tokens. And of course, we use AI even more than ever today. So we need a special computer designed for thinking, designed for reasoning, and that's what Blackwell is, a thinking machine. These Blackwells will go into new types of data centers, essentially AI factories, designed for one thing and one thing only. And these AI factories are going to generate tokens, and these tokens are going to become your food, little Greg. Yeah, I know. I know. And what's really, really incredible, I'm so happy to see that Europe is going all in on AI. The amount of AI infrastructure being built here will increase by an order of magnitude in the next couple of years. I want to thank all of you for your partnership. Have a great Vivatech. Thank you. Say bye-bye. Say bye-bye. Take a bunch of pictures. Take a bunch of pictures. Take a bunch of pictures. Yeah?